This talk is about organizing infrastructure and configuration and workflow that I've been working on at Home Depot. And Evan has been helping with that too, not at Home Depot. That's my company, where I work at.
Hey everyone, my name is Google Cloud Platform. I'm a vast array of data centers that provide on-demand access to compute storage and networking for customers. My name is Evan Brown. I work for Google Cloud up in Seattle. I work on a team called Cloud Graphite. We're a team of software engineers, and our mission is to engage with third-party open source projects and build integrations into those tools for Google Cloud. So I'm extremely fortunate to work on Terraform, Packer, and some of the other HashiCorp tools on behalf of Google, and really excited to be here today. I'm going to pop in just 2 more times. Adron's going to give the majority of the information here. I'm literally going to pop in from behind the curtain and throw out a couple of hot tips about best practices that I've seen working with Cloud Platform. But in the meantime, enjoy Adron.
So don't get scared when the man behind the curtain pops out of the curtain. So the work we do at Home Depot, and this is where the connection starts to come together for how Evan and I are connected. I work with a group in Home Depot that is specifically called the Quote Center. And if you've ever gone into a Home Depot store and gone to the custom order desk, that is our software that basically runs that desk. And what it does is it is used to put together orders for all of the builders out there that come in and are building houses and apartments and things like that. We help to get quotes together and then get that product delivered to them. Home Depot is a very polyglot environment. We have Java, we have Go, we have C#, we have some F#, we have lots of JavaScript because it's everywhere today. And that's kind of what and where we work with as far as languages. We also have on-site data center things. We have things hosted in various cloud providers. And we're in the process of moving a lot of that to Google Cloud Platform. So as we have began that journey of moving a lot of our infrastructure and apps and things like that to Google Cloud, this migration has caused us to take a lot of steps back and look at where we are and where we're going. And I've broken that out into 3 eras, which I found kind of interesting as I was watching the keynote this morning, because these 3 eras of application development kind of coincide with what Mitchell and the rest of the crew were talking about this morning. I've broken them out with different names, however. So the first one is the Iron Throne era. Now, this is an era where systems sort of worked. And sometimes you can move the applications. Some of them are sort of internet ready, or we pretend that they are. And there's a lot of meat cloud. There's a lot of human beings involved in these processes and practices to get any of this era of technology modernized. But it is difficult as Circe has lost her children, so anything from this era is usually a very, very touchy subject. So the Renaissance era, as we have stepped into that era, the applications get a little simpler. They're very easy to move to Google Compute Engine because it's usually an app and a database. So we put a database in Google Cloud and we put an app in Google Cloud. And it's generally like system applications. This is where things like Cloud Foundry comes in handy. We use that quite a bit at Home Depot, where it's easy to just get these applications moved right over there. But there is the Iron Man era, where we have a different baseline. We're not just copying applications over there with an application and a database. We're actually setting up continuous integration and deployment systems so that we have more monitoring and information about what these applications are and where they're going and why. Because we don't want to just throw apps up there and then have them running. They may be apps we need, they might not be apps. We don't always know that. So this era, we have more information about the apps. They're almost on the verge of being somewhat intelligent. As we move past that, we get into what I like to dub the Jarvis era, but that's for a topic another day. And Adron also mentioned that, where you started to get into intelligent systems. I won't say they become sentient or anything, but we're getting close. So the Iron Throne features are basically handcrafted. You have disparate logins. You might not have SSO, things like that. Sometimes you might see a FoxPro or a VB6 application or Delphi, something like that. And somehow you have to get it into a usable state. And I was going to show you a demo, but applications from this era are far too risky to show in public. So I'm just going to keep it nice and safe, and we're going to skip demos for that era. The Renaissance era, though, we actually step into a bit of freedom and liberty around the applications we have because of their a little bit cleaner separation of concerns. But again, like I was saying earlier, it's still definitely data and an app. They're very divided, and often you see entities within departments divided. It's the application development team and the database team and the ops team, and they're disparate, and they may not like each other. I know all of us here get along perfectly, but sometimes it happens. So I have a little bit of an example of what I consider a Renaissance application or a Renaissance setup, and I'm going to show you how I've organized it. I'm not by any means saying that this is the way you should do it. I'm just saying that this is the way that I did it. So this is simply Terraform and Packer elements that I use to create the base images and then deploy Elasticsearch out into the cloud. Now, the reason I've put this into the Renaissance era is because I can deploy this setup all day long, and I get an Elasticsearch cluster, and that's nice. But I don't know what is connected to the Elasticsearch cluster. I don't have any monitoring on it. It's simply the service is deployed. If I pull it up in code, you can see how I'm organizing the code a little bit. So I just simply have a Packer directory with the template, some standard configuration stuff, and then I have provisioners that launch some simple shell scripts that I keep in the Packer directory. That's used to create the image. Generally speaking, I use Atlas to spool this stuff together into a deployment pipeline. And it knows to, based on branch, launch and initiate a Packer build, or to launch and initiate a Terraform apply. Down below, I have various Terraform things, the connection resource, DNS records, and all of that. And then I have a scripts directory. The scripts directory are actually post-execution stuff. So Terraform runs and then initiates these scripts, and it does some final tweaking on like the configuration and Elasticsearch. And if I run that, it should just work. So that's launching at the moment. But that's a Renaissance era application. Easy to deploy. It'll be out there in however long it takes to launch the instances, right? Not difficult from an operational perspective once I have this stuff created. But again, I have no insight into what is happening, what is using this once it's out there in production. Like, do I have one application using it? Do I have 50? No idea, no visibility into that. It should be popping up any second now. Oh, yeah, cool. See, live demos. Oh, well, anyway, that would be popping up if that had not happened. Loading. Come on. There we go. So that's the Renaissance app. Basic idea. You saw how simply I divided it out and how I launch it. And at this point, I have this crazy green screen, so I remember what I'm doing. The person behind the curtain is coming to talk about some of the organizational stuff in Google Cloud Platform.
I should be on. Can you hear me okay? All right. Napa Narnia is weird. Aslan is a wine snob. There's no Turkish delights. It's all Petit Verdot. Thought of that. Like when you're back there in the dark, you think of weird things. So Google Cloud Platform has projects, this concept called a project. Who has used projects in GCP before? Awesome. So GCP projects are incredibly powerful, and you should use them to organize your teams and your applications. So a project isolates three key things. It isolates your resources, so your VMs, your disks, your networks. It isolates the quotas associated with those resources, so how many cores you can launch, and billing as well. So when you're in the console, Adron was just in the console, you see a list of projects in the top. So the selected project is the context that you're working in. There's also a projects API, so you can use gcloud projects list, create, delete, to modify or create these projects. They're free things. So if you've got an application called App1 that has a dev environment, you would probably have a project for dev. And that environment would have an associated identity and access management policy, some VMs, some networks and firewalls, storage configuration, and quota for that appropriate environment. And the quota would probably be small in this case, which helps constrain cost abnormalities. Same application, but production may have an identical IAM policy. It may be different, but it's going to have the same topology, right? The infrastructure topology that you define with Terraform will be identical. The quota is probably going to be bigger. So you'll have an attached quota that allows you to create more VMs, provision more cores, more disks, whatever your application needs. And possible that you've got an application, somewhat extreme example, that is just storage-based. Maybe it's direct to GCS, Google Cloud Storage uploads. And in that case, projects allow you to selectively enable and disable APIs. So you can have a project that only has the Google Cloud Storage API enabled and has some quota and identity and access management associated with it. So silo with projects according to your needs, maybe by application, vertical, team, or environment. And terraform all of this, right? Currently, you cannot terraform quotas, but think about terraforming your resources, your network descriptions, firewalls, and especially your IAM policies. So at the keynote this morning, they talked about the three pillars, and the core pillar there was security. And so an identity and access management policy is certainly something that you would version control. So let's talk about what that looks like briefly in a Terraform template. We've got a in development resource type called Google Project, and this will allow you to reference a project that you have and use it inside of Terraform. So I've just got a variable that is the project ID. You will have a policy data member of this resource type, and that is a reference to what will be the first data source. Data source is an awesome feature in Terraform. Was really excited to see that. So you can define your IAM policy as a data source and then reference it into a project. Policy is very straightforward. It's very simple. It has bindings, and a binding is simply an association of a role. So for the first binding, the role is object viewer and a collection of members, principals, or users. So it could be Gmail accounts, it could be service accounts, it could be Hotmail accounts. I would never let Sergey Brin be admin member of my project, but just to illustrate the ability to have multiple bindings associated with a project. So IAM policies are coming soon. I'm actually kind of excited to do this. I'm going to merge one of our most important PRs to date on stage. So build off master, and you can attach policies to your projects. Coming in the next few months, we'll have the concept of an entire project template. So a Terraform template that not only says what policy should be attached to an existing project, but will actually allow you to define an entire encapsulated project, including the APIs that should be enabled or disabled in that project. Distribute that template, a person executes it with Terraform, they'll get a brand new, pristine project. We'll support project delete as well, and GCP has the concept of a recycle bin. So you delete a project and it goes into like a relaxed state for 7 days. It goes dormant for 7 days. You don't get billed, so it gives you this grace period to like undelete. If you've ever run trainings or things where people spin stuff up for a day or two and then need to tear it down, give each person a project, delete the project, everything goes away with it.
Now back to the curtain. Okay, is it hot back there? So, as we come into the Iron Man era, and that was pretty cool, by the way. Good merge, man. I'm glad to see that worked for you versus my Terraform deployment. So, in the Iron Man era, we start to focus on stepping past just deploying an application or deploying a database or deploying a single part of the ecosystem. And what we're working toward at Home Depot is to be able to not just have a deployment or a application even, but to have the application know where and how it's going to be deployed and what resources it needs to be deployed so that it is responsible for understanding its ecosystem that it is deployed into and deploying with. So I have a little bit of a demo for that. It's just a simple project layout to kind of plant some seeds about what I'm thinking about as, get rid of that error, as I've been working on these projects. They're very much in kind of a prototype state. Let's see here. But I give them nice prototype names too, like symmetrical spork. It's very nice being able to name things like that because then I can just use the GitHub default, whatever that is, usually something completely off the wall, but it livens up corporate meetings. So take a look at that. This is the root of what most of these projects look like. One of the things that you can think about in this type of project is something that I've been reading a bit about. Quite a few people here probably have had their fingers in this effort, but the autopilot pattern. The idea that an application can deploy itself, knows where it goes, has its delivery mechanisms all in place and everything in one place. I also want to point out that I like to differentiate that this is not a monorepo. Sure, a monorepo would inherently have these capabilities. It would have all the infrastructure and all the other stuff in it. But this can be used for independent applications. It's just the infrastructure and other pieces that go with that application. In this particular situation, I have a simple Node app that is very hello world-like. And beyond that, I have the Terraform files and the Packer bits. So this project is not complete. This is a prototype that I'm working on to show and teach in some of the future things that I'm doing. But basically what I do, the idea is Packer, I initiate either manually at the command line to talk through how that is done so that I bake in the Packer image with the appropriate node services and monitoring elements. And then I move on to the Terraform bits, standard connection, instance 1 and 2, so that I can cluster that, and some basic network elements, things like that, so that overall I have the groundwork for an application, everything in one place that knows where it's going to be deployed to, or knows what it needs to be deployed, and it has the application code that will be deployed also. As you can see here, I'm starting to move forward with the Jarvis idea already, and I have a health check. One of the things that I love about GCP is there's a lot of things in there that help you set up things for the Jarvis era already. Auto-scaling, monitoring, things like that. They got a lot of features there already, and that's nice, because then I don't have to build them manually. Overall, though, to summarize the Iron Man era, I break it out so that I have all of the infrastructure, the networking, the instances, the configuration for those things, the scripts, and the application code in the same project to be able to deploy that itself. And soon, hopefully, in the next coming months, I'll have that be able to be deployed, but also monitor, auto-scale, do other features to itself too. Less work for me, less need for beepers or whatever we use these days. Just makes life better that way. At this point, I'm going to hand it back to the wizard for a moment.
Thanks, Adron. We've got doing well on time. So maybe these won't be the quickest hot tips, but they're still hot tips. And there's 3 of them. The first, when you launch a Google Compute Engine VM, if you've launched an EC2 instance or a GCE VM before, you've probably used metadata, right? Some key value pairs that the instance has access to from inside the instance. What's that IP address that you hit to get that? 169.254.169.254. Typically, that metadata is immutable. You set it, you run the instance, and you can't change it. With GCE, VM metadata is mutable. So you can launch an instance, let it boot up, run upstart, and then you can modify the metadata through a set metadata API call, and the metadata will get propagated, actually pushed into the VM. And I'll show you an example of using curl to do a hanging HTTP GET that just waits for the metadata service to push the new information down. So if we've got a manifest here with a GCE VM and a metadata stanza that says some config equals value, then from that VM, once it's launched, we could curl 169.254, compute attributes, metadata, some underscore config, and we would get value. And that's helpful. We can modify the Terraform manifest and add another metadata value called some other config in this case. And from the VM, if we curl the metadata endpoint and add this recursive equals true, wait for changes equals true query parameter, it's effectively an HTTP long pull against the VM metadata service. And when that change is propagated, and anecdotally it's order of seconds for that to happen, the value will be pushed down as a JSON block. So it's a really cheap, built-in, it's free, it's not cheap, way to do key value storage for configuration type data to VMs. That's hot tip number 1. Number 2, probably my favorite feature about Google Cloud Platform ever, and that is a network is global, a subnetwork is regional, and everything is connected by private Google-owned fiber. So let's step back to when I say network is global, what does that mean? When you have a project, you get a default network. You can use that, or you can customize your network topology. So if we create a network called Terraform, that network spans the entire globe of GCP. So every region where GCP is deployed, Europe, US, Asia, the network will allow you to launch instances into it from any region in the world. When you create a subnetwork, let's say in our Terraform network, we create a subnetwork in Oregon, one in Central and another in US East. Those aren't restricted to the availability zone or a specific availability zone, but rather the entire region that the subnetwork exists in. So what that means is a subnetwork in US West can communicate via the private IP address or the RFC 1918 address of a VM in Europe or Asia or the East Coast. There's no VPN required. They exist on the same network. So it's a really powerful feature if you're not using public IP addresses and you don't want to have or manage subnetworks per zone. You get that global and regional distribution by default. Third and final bit, the load balancer is global. So when you provision a load balancer on Google Compute Engine, you're actually provisioning configuration into our software-defined network, or Andromeda. So you get an anycast static IP address. It's one address, that is your load balancer everywhere in the world, and the load balancer supports URL mapping. So there's no CNAME required. You can use A records for the load balancer. There's no pre-warming required, so it's not a VM or a scaled VM. It is literally part of the network fabric that Google runs globally. There's no headphone jack on the load balancer. We didn't even have to take it off because it was never there. We're ahead of our time. Thanks to HashiCorp folks. Thanks to everyone for taking time away from work and family to come out here and to sit in this room and listen to us talk. I'm Evan D. Brown on Twitter and GitHub. I will be on the stage after to answer questions like walk-up questions or out there.
And I am Adron Hall, available on Twitter. Also have an Adron Orange account for my Home Depot work. I also am leading efforts to open source a lot of what we're doing, which will be released on the Home Depot organization on GitHub. That's going to include all sorts of stuff, everything from like client-side JavaScript to Terraform modules to other things like that. And we'll also be putting forth efforts to work with HashiCorp to add some GCP modules, which is super exciting to me. I'm very excited to work on some of that stuff.
You haven't fixed that bug.
I should have him fix that bug. But we'll get you to do it. Also, for that work, Home Depot, things that I'm working on myself, blog.adron.me. And that's it. Thank you very much.